The best thing about using a parabola is it is very useful for finding minimum and maximum values, especially whenever you have some real life like projectiles or anything else that follows a parabolic path. The way to find your maximum and minimum, well, these are going to be always located at your vertex. So if we can find our vertex, then you can find your maximum and minimum values. Now your max and min values are also, these are your y values. So you're trying to find out how high something is or how low something is. That is your y value. That is not your x value. However, you need to find your x value first in order to find your y value. So if your a is greater than 0, that means your graph is going to be opening up, which means you would have a minimum. So if we have a minimum, then what you're going to do is you're going to use the formula x equals negative b over 2a, and that will help you find out what your x value is. In order to find out what your y value is, then you just plug that x back into your function. So if x is equal to negative b over 2a, we just plug negative b over 2a, whatever that number is in your equation, that's going to be your minimum value. Same thing with your max value. Okay, if your a is less than 0, that means you're going to have a maximum. You still use negative b over 2a, and remember, if you remember from algebra 2, that's how you find your axis of symmetry. You can find your max value by plugging that in and finding your y value after plugging in your x. So let's look at example 5. And what we have here is we're going to find the max height of a projectile. So a football is thrown at a point 6 feet above the ground at a velocity of 60 feet per second at an angle of 45 degrees with respect to the ground. The path of the football is given by the function f of x equals negative 0.0168 x squared plus x plus 6, comma, where f of x is the height of the football in feet and x is your horizontal distance from the quarterback. What is the max height reached by the football? So algebraically, you can do this two different ways. You can do it algebraically, and you can also do it graphically. So algebraically, if you are given this function of f of x equals negative 0.0168 x squared plus x plus 6, to find your max height algebraically, we need to know what our vertex is. So your vertex is x comma y, but in order to figure out your y, we need to do x equals negative b over 2a. So what we're going to plug in for our b, this negative value, your b is, well, there is just a 1 in front of this x, so we're going to say a negative 1, and that will all be divided by 2 times your a, which in this case, our a is this big honker here. So we're going to say 2 times a negative 0.0168. So when we plug this into our calculator, you actually get a decent number. So let's plug this in our calculator, and we're going to say negative 1 divided by, now you should really put this in parentheses because this is going to take a negative 1 divided by 2 and then multiply that answer by negative 0.01x, all that other fun stuff. So you want to make sure you put it in parentheses, so you get negative 0.0168 times 2 in parentheses, and hit enter. And this is your x value. So your x value ends up being, we'll make this a 29.76. So 29.76. Now in the context of this problem, x is your horizontal distance from the quarterback. So he threw it almost 30 feet. And this is in feet, not yards. Otherwise it's a big difference. So now in order to figure out what your y value is, we're going to find out what f of 29.76 is. So we're going to plug in 29.76 into everywhere there is an x. We're going to say negative 0.0168 times 29.76. I'd recommend using 0.76 and not rounding to 30, just saying. Plus, here we're going to have another 29.76 plus 6. So when you plug this into your calculator, it should spit out your answer. So let's say negative 0.0168, parentheses, you have 29.76 in parentheses squared plus 29.76 plus 6. Here is your max height. So our max height is a 20.9 feet. So which is close to 21 feet. So you could round up to 21 feet if you want, or if you put 20.9 feet, that's going to be your maximum height. So that is how you find it algebraically. Now if we want to find it graphically, what we do is we just plug it into our calculator, into the y equals, and that's going to give us a negative 0.168 x squared plus an x plus 6, and we need to make sure we get all this other junk cleared out of here real quick, and almost done. Alright, and then make sure you turn off your plot. Your plot 1 should not be on. So here is your graph, and let's hit graph, and I don't see our equation. That's a bummer. So let's go to our standard mode, our zoom 6. So here's part of our graph. Well, we see it go up, we see it go back down, and let's find our max value. So we go second calc, and we want to find our max value, so we hit 4, and here's a left bound, so we'll hit that. Looks like our right bound is a little bit further to the right. You know what, I thought this didn't look right. We'll see if you notice the mistake, because here's our, get that in there. Okay, that's to the right of our max value. Hit, maybe, and maybe it will stop. I don't know if it will or not. So I'm going to hit enter. Sure, sounds good. And this doesn't give us our same value as our algebraically. Well, if you look back at our equation, somebody typed it in wrong. Somebody forgot a 1. So let's cursor over to the 6, hit second insert. This is how you can insert a number. Type a 1 in there, and then hit your graph button. I think this will give you a little bit different graph. Oh my gosh, just that little 1 makes a huge difference. So we're going to hit zoom 0. That didn't help out too much, so we need to make our x values bigger. So go to your window, make your x max, let's make our x min 0. Let's make our x max, but you can't throw it any more than 100 feet. So, or 1,000. So maybe make this a 100. Enter. And we'll go back to our graph. Actually, we should make our y min a 0, and make our y max maybe 25. And these numbers you just have to fiddle with a little bit. So we go to the graph. Now we see we have a max value. So let's go to second trace. Hit 4 for max. And you go to the left. So that's 50. I'm going to say 10 for my left bound. And then I can say 50 for my right bound. So I'm going to find a max in between those 2 points. Hit enter. 29.76, 20.88. There is your max value. So just like we did on your algebraically, 20.9 feet. So that's how you mess around with quadratics, and that's how you play with your calculator. So I hope you enjoyed lesson 2.1, quadratic functions.